Your internet package says 300 megabits per second. But upstairs? Videos buffer. Video calls freeze. Online games lag. And somehow the Wi-Fi signal completely disappears in the room where you need it most. So what's actually causing it? Is your internet provider slowing you down? Do you need a more expensive router? Or is there a hidden problem inside your home that's quietly destroying your Wi-Fi performance? Today, we're going to investigate a real-world weak Wi-Fi problem, uncover the exact causes, test every floor of the house, and reveal the upgrade that transformed a frustrating network into fast, reliable coverage everywhere. And before we're done, you'll learn why one of the most commonly recommended Wi-Fi solutions may actually be making your network worse. Let's begin. Meet a typical family. Their internet plan is fast. Their modem works. Yet every day they deal with buffering videos, slow downloads, and dropped connections. The strange part? The problems aren't happening everywhere. The Wi-Fi works reasonably well in some rooms, but move to another floor and performance collapses. This situation is extremely common. Many homeowners assume they need faster internet. But in reality, internet speed and Wi-Fi coverage are two completely different things. Think of it this way. Your internet connection is the water entering your house. Your Wi-Fi network is the plumbing distributing that water. Even if plenty of water enters the home, poor plumbing can prevent it from reaching every room. So before buying new equipment, we need to identify where the bottleneck actually exists. The first step is checking the physical infrastructure. Many Wi-Fi issues begin long before the wireless signal leaves the router. Loose cables, damaged connectors, old splitters, poor signal amplification. Any of these can create problems. A healthy network starts with a healthy incoming connection. After inspecting the wiring and connections, everything appears normal. No major issues, no damaged cables, no unnecessary splitters reducing signal quality. That's good news. It means the problem probably isn't entering the house. Now we need proof. So let's run a hardwired speed test. A wired connection removes Wi-Fi from the equation. This allows us to measure the true speed being delivered by the internet provider. The test begins. Download speed rises rapidly. The results are excellent. This confirms something important. The internet service itself is not the problem. The bandwidth is available. Somewhere between the modem and the devices, performance is being lost. Now the investigation gets interesting. To understand what's happening, we test Wi-Fi performance throughout the entire house. First floor, strong signal, fast speeds. Everything looks normal. Next, we move upstairs. The speed drops noticeably. Walls, floors, pipes, wiring, furniture, and building materials are all absorbing and weakening the signal. Then we test the basement. The results are shocking. What started as a strong connection upstairs has become a weak and unreliable signal. This explains the buffering. This explains the dropped video calls. This explains why streaming becomes frustrating. The Wi-Fi signal is simply struggling to reach every corner of the home. But why does this happen? Because Wi-Fi behaves more like light than people realize. Imagine placing a flashlight in one room. The closer you are, the brighter it appears. Move farther away. Add walls. Add obstacles. Eventually, the light becomes dim. Wi-Fi works the same way. Distance and obstacles reduce signal strength. The farther your devices are from the router, the weaker the connection becomes. And in larger homes, one router often isn't enough. At this point, many people buy a Wi-Fi extender. And that's where things often go wrong. Traditional extenders receive a Wi-Fi signal and then retransmit it. Sounds helpful, right? Unfortunately, there's a trade-off. Many older extenders must spend time receiving data before transmitting it again. This process can reduce performance significantly. In simple terms, you're extending the signal, but often sacrificing speed. That's why some people install extenders and still experience buffering. Coverage improves. Performance doesn't. Fortunately, newer technology offers a better solution. Mesh networking. A mesh system uses multiple access points working together as one intelligent network. Instead of relying on a single router to reach every room, several units distribute coverage throughout the house. Your phone, tablet, laptop, smart TV, and gaming console automatically connect to the strongest node available. You don't have to switch networks. You don't have to reconnect manually. The system manages everything in the background. Advanced tri-band mesh systems are even more impressive. They dedicate a separate communication channel between nodes. This means the units can exchange data efficiently while preserving performance for connected devices. The result? Better coverage, better reliability, and significantly improved speeds throughout the home. There's another upgrade many homeowners overlook: power protection. A sudden power outage can instantly disconnect your network. Voltage spikes can also damage sensitive electronics. That's why many professionals recommend connecting networking equipment to an uninterruptible power supply, or UPS. A UPS provides battery backup and surge protection. If the power fails, your modem and networking equipment can continue operating temporarily. For remote work, online learning, security cameras, and smart home systems, this extra protection can be extremely valuable. The installation process is surprisingly simple. The main mesh router connects directly to the modem. Additional nodes are strategically placed throughout the house, one on the main floor, another upstairs, another closer to problem areas. Placement matters. Too close together and coverage overlaps unnecessarily. Too far apart and communication weakens. The goal is creating a seamless blanket of wireless coverage. Once configured, the entire network appears as one unified Wi-Fi system. Now it's time for the moment everyone has been waiting for. The final test. The first floor is tested again. Excellent speeds. Next comes the upstairs. The difference is dramatic. Areas that once struggled now perform smoothly. Finally, the basement. Previously the worst performing location in the house. The test begins. The numbers climb, and keep climbing. The dead zone is gone. Streaming works. Video calls work. Downloads finish faster. The entire home now enjoys strong, reliable coverage. Not because the internet plan changed, not because the provider increased speeds, but because the Wi-Fi network itself was redesigned correctly. If your Wi-Fi feels slow, don't immediately blame your internet provider. Start by testing. Check your wired speeds. Measure performance in different rooms. Identify where signal loss occurs. And remember, more internet speed doesn't always solve Wi-Fi problems. Sometimes the real solution is improving how that speed reaches your devices. A properly designed network can completely transform your online experience. From buffering and frustration, to fast, reliable connectivity in every room. If you found this video helpful, make sure to subscribe and turn on notifications. And let us know in the comments, what's the biggest Wi-Fi problem you're dealing with right now? Thanks for watching, and we'll see you in the next video.